Hello and welcome back to the wonderful world of factoring trinomials. Our goal continues to be factoring quadratics in the form ax squared plus bx plus c. Now so far what you've seen is when a is equal to 1. A is equal to 1. So let me just show you down here. You've seen this problem here, and if you recall, this one factors pretty quickly to x plus 3 times x plus 4, and we use the Snowflake to do that. Now let's make it a little bit more difficult by making this in the front a not 1, so like a 2 or a 3, etc. So join me here in example C. We have some more crazy, so we're going to factor the following. Factor. Now let me remember what factor means. Factor means to convert into a multiplication problem. So as a reminder, if I gave you 12 and I asked you to factor it, some of you might say 3 and 4. Why? Because 3 times 4. Or 12 times 1, 6 times 2, and those are the nice clean factors. Clearly there are other factors. 2.5 times something would give you a 12, but when we say factor, generally we mean the integers that factor and to make that number. So factor is to make into a multiplication problem, because currently this is an addition problem. This quadratic plus a linear term plus a constant. So we want to convert this to a multiplication. Now let's set this up. Remember, the moment we see that we have a square here, then most likely we can do our Snowflake method. So start with the x, and then so like an asterisk here. Always place a times c, so remember what that is, a times c, that goes on the top, 15. And then next, b goes on the bottom, b goes on the bottom, positive 8 down there. And as we mentioned before, this unit right here goes to the sides there in the wings, 3x and 3x. We're ignoring this square right here. So it's just the coefficient and just the variable goes there. And now we ask ourselves this question. What two numbers multiply to 15 but add to 8? What factors of 15 sum to 8? Alright, so first off, if you can't see it very quickly, some of you might say 15 and 1, but 15 plus 1 is too big, 16. So the only other option is 5 and 3. Oh, but what if I wrote 3 and 5? Actually, doesn't matter. So I'll write those a little bit bigger because that's where we're going to end up being. 5 here, 3 here. Now, one thing we didn't do on the previous problems, but we did ask ourselves, pretend this was a fraction and see if we can reduce it. Well, 3 and 5 do not simplify, but 3 and 3 do simplify. Well, this reduces here to just an x or 1x and a 1 down below, because 3 divided by 3 reduced to 1. And this one stays as is. So here are my factors. 3x plus 5 and x plus 1. So how do I know I'm right? So I'm going to do a quick check on this one here. Remember, the check is just a double distribution. Or if you want to do a grid real quick, you can do that. But I'll do double distribution for this problem here. So that gives me a 3x squared. And then this one here gives me a positive 3x. And then I multiply the 5 out. So 5 times x is 5x. And lastly, the 5 goes to the 1. 5 times 1. And now we combine like terms. Just the linear there. And then I get 8x there and a 5 there. Oh, wait a minute. 3x squared plus 8x plus 5. 3x squared plus 8x plus 5. Ding, 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 ding. So now we commit to this as the answer. This is my answer. And we don't need those. Oopsie. We don't need those blocks there. Or excuse me, the arcs there. And there we go. So box or circle your answer when you're done. Commit to it. Now, if you ask yourself, but how do I know if I'm right? I don't have an answer key. Yes, you do. just multiply it out. So let's do another problem over here. 2x squared plus x minus 21. So just over on the side, away from, this is me showing my work, but it's not, I'm not doing it over here to get in the way, because essentially what I'm doing is I'm going to, underneath this, I'm going to write my factors. All right, so how do we set this up? Recall that it is the a times c goes on the top, so that's a negative 42, and b goes on the bottom, positive 1. All right, then our leading term minus the exponent, or not including the exponent, so 2x goes there. And now we just ask ourselves this question: what multiplies to this but adds to this? So if you need to, because like me, not everything just shows up in my head immediately, okay? So you might want to start making your lists. Okay, well, 2 and 21 and 3 and 14. Feel free to use a calculator. I don't expect you to have all of these completely memorized. 6 and 7. But notice what happens. I'm multiplying to be a negative, so one of these needs to be a negative, but I sum to a positive. So if I'm multiplying to a negative but summing to a positive, that means the larger looking number is the one that's positive, and the smaller one is negative. So these are the actual factors I'm considering, and which pair add to 1. And there we go. So 7 there, and negative 6 there. Always ask ourselves now this: if this were a fraction, can I reduce it? Oh, 2x and 7? No. 2x and negative. This one does. I can divide both by 3. Excuse me, by 2. 2 divided by 2 is 1. Negative 6 divided by 2 is negative 3. So those are my factors. So bring those over. 2x plus 7, and then the x minus the 3. X minus the 3. Well, how do I know if I'm correct? Well, I'm going to check this one with grid. Real quick. 2x plus 7, and again, it doesn't matter where you place these, as long as you place them in order. 2x plus 7 could have gone up here. Now, multiply out. This one's a 2x squared, this one's a 7x, this one's a negative 6x, and this one's a negative 21. These two here combine, so we get 2x squared plus x minus 21, and dun 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 dun, that's exactly the same. So now I commit to my answer by putting a box or a ring around it. Dun 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 dun. Now it is your turn. So practice these, pause, and check your answer. And there are your results. Remember, always just do a quick mental check here. 2x times 5x is 10x squared. 2x times 1 is 2x, and this is 15x, so together they're 17x, and then 3 times 1 is 3. You can do the same over there as well. All right. Now let's get a little bit more complicated, and this is where we're actually going to end. So a key thing also is, just like we looked at it a few sections ago, is don't forget about the greatest common factor, the GCF. So we're going to check those first. In fact, I should have mentioned that at the very beginning. Always check GCF first. So let's double check here. So before I set up to try to do a snowflake, which currently only works when this is a square, how can I factor this? Well, notice that each coefficient can be divided by 3, and there's also an x in each term there. So that means I can effectively factor out a 3x. So when I divide the first term by a 3x, I'm only left with an x squared. Now divide this second term by a 3x, so 15 divided by 3 is going to be a 5, positive 5, and then x squared divided by x is going to be just an x. And lastly, negative 18 divided by a positive 3 is a negative 6, and then the x divided by the x is just a 1, so I can leave it like this. Now we're asked to factor this, and 3x is already part of the factor, so I'm going to bring that down. But now, over on the side, I'm just going to snowflake what I wrote in black there. So negative 6 goes on the top, x is in the wings, and b goes on the bottom, 5. And so what two numbers multiply to a negative 6 and add to a 5? And my first instinct might be this, 2 and 3, because 2 plus 3 is 5. But wait a tick. 2 minus 3 is a negative 1. 2 times a negative 3 is a negative 6. So that works for half of it, but not all of it. So it's actually going to be 6 and negative 1. Again, 6 times negative 1 is negative 6. 6 minus 1 is a 5. So there we go. Notice the wings don't reduce any further, so x plus 6 is one of my factors. And then x minus 1 is my other factor. And here is factored completely. I didn't just stop the first step. I factored as far as I could go, sort of like prime factorization. Let me just refresh that. What if I asked you to factor 12 completely? And you said, oh, 3 and 4 and I'm done. Well, actually, the 4 can be reduced even further. So factoring it all the way down would be 2 squared times 3, called prime factorization. So this is what we mean over here when we say factor completely is similar to prime factorization. And there we go. Again, we can always multiply out. You can distribute here and then double distribute, and it should end up back to there. Notice I do want to see on your paper as you're showing work the snowflake just over on the side, because that shows me what you are thinking. Okay, next one here. So notice that GCF, check first here. Both of these I can divide by 5, and both of these I can divide by x. So I'm going to factor out a 5x, and that gives me here x squared minus 9. Now, there's no work to show because 5x, one thing I notice here is that this is a difference of squares. We already talked about that pattern, the difference of square pattern, because we saw that if I had a minus b times a plus b, that's going to equal a squared minus b squared, a difference of squares. So I actually know the factors here, but just so that we can keep it consistent, let's go ahead and do snowflake with the inside here, x squared minus 9. So what is a? A is the 1 right there. And then what is the c? The c is the negative 9. So I'm going to put negative 9 on top. But what's the b? What's the term that's in front of the x? And that's often in the middle here. Not often, but in standard form it would be in the middle. Well, there isn't. I just want to show you what this looks like when we're writing it out completely. Again, that's more work than we need to, but just remember that the linear term is a 0. It's not there, so it's a 0. So the b is effectively a 0. So I put x's in the wings, and I ask myself this question: what two numbers multiply to a negative 9 but add to a 0? One thing I want to point out to you, two numbers that add to 0 have to be opposite. 6 plus a negative 6, 12 plus a negative 12, or in our case, a 3 and a negative 3. Again, it doesn't matter which order you write those in. Notice my wings do not reduce further, so those are my factors, also known as linear factors. And we are done. 5x times x plus 3 times x minus 3. I don't write this one as like x minus 3 with a square right there, because this is a plus and that's a minus. They're not the same, so I can't say, oh, it's the same thing by itself. These are different. They're conjugates, not the same thing. All right. Your turn on these ones here. Pause and check your results. Now you can check your answer here, but this one I do want to set you up a bit. Pause and then check your answer on this one. So just setting it up. Notice there is an x in each of these terms, so I can factor out an x using GCF. And then notice all of these are even, so I can factor out a 2. So let me go ahead and do that. Factor out a 2x, and we get 12x squared plus 16x minus 3. So now how do we factor this part inside? Well, let's set up a snowflake. Negative 36 on top, 12 times negative 3. b goes on the bottom, 16, and 12x in the wings. Now go ahead and work through that one, and then reduce the wings. Both of these will reduce, and then put the answer down. Pause and check. And here's your final answer. Make sure to be showing your work here. Alright, now spend some time working on these problems on page 4 and check your work by multiplying out.